In this video, we will look at the properties of sealing chip. The NZTA specification for sealing chip is NZTA M6 specifications for sealing chip. It sets out the requirements for chip sealing and chip. Sealing chip has to be able to resist the traffic loadings without crushing. Chip is tested using the crushing resistance test, which is the same test that is used for base course aggregate and is shown in the top diagram. The load applied is more than the base course aggregate, as the chip takes all of the traffic load directly and so needs to be stronger. Basically, the test involves applying a load of 230 kilonewtons to a sample of chip over a period of 10 minutes and then weighing how much material is smaller than the original chip size. This smaller material would have resulted from chips breaking into smaller pieces and so is a good indication of how much of the chip has been crushed. The specification requires that no more than 10% of the sample weight be crushed material. Sealing chip is also tested for weathering resistance. Once again, the test used on chip is the same test as done for base course. The chip is exposed to repeated cycles of heating, cooling, wetting and drying, and the extent of the breakdown of the chip is assessed. The specification requires that sealing chip have a weathering quality index of either AA or BA, which is a higher requirement than that required for base course. This is because the chip is directly exposed to the weather, so it needs better weather resistance. The chip also needs to be free of dust, clay and other weak particles. These particles take up space in the chip seal surface, but break up and leave a gap, reducing the interlock of the chip seal surface. This can cause other chip to become dislodged from the surface, leading to a deterioration of the surface. The specification requires that the chip mix have less than 1% of these weak particles. The macro texture of the chip relates to the surface of the chip itself. The chips need to have a specified amount of roughness, as a polished smooth surface does not allow good contact between the vehicle tires and the chip, so reducing skid resistance. You cannot see the microtexture, but you can feel it by rubbing the chip in your fingers. It should feel rough to the touch, like fine sandpaper. If it feels smooth, then it may not be rough enough. The roughness is measured by the polished stone value. Chips need to be roughly cuboid in shape. Elongated chip will just roll over on its side and may go below the binder surface, creating a gap in the seal. However, chip will have a longer and shorter sides. The longest side on the chip is called the greatest dimension, while the shortest is the least dimension, as shown by the bottom diagram. This test involves measuring the greatest and least dimensions of a sample of chips and determining the averages to get the average greatest dimension, or AGD, and the least greatest dimension, or ALD. The ratio of the average greatest dimension to the average least dimension should not be less than 2.2 times, which effectively means that the chip's shortest side should be about half the length of the longest side. There is also a requirement for testing the cleanliness of the chip on site. This test measures the amount of clay, dust, and other fine particles on the chip. These particles can adhere to the chip surface, preventing proper adhesion between the chip and the binder. The test is undertaken on site, as it may have become contaminated during the transportation or storage processes. This illustrates the importance of protecting the chip from dust and other sources of contamination while it is stored on site. Chip provides the contact between tires and the road surface. Therefore, a certain proportion of the chip needs to sit above the binder. The binder does not have the strength to resist traffic loads directly, so the chip should be in contact with the tire and only the chip. The chip needs to be raised above the binder surface to allow water to drain across the surface while still allowing tires to maintain contact with the road. It also needs to be remembered that the chip layer is usually about the same average height as the average least dimension of that chip, as the chip will roll over on its long side during rolling. The binder needs to be applied at a rate to ensure that the chip is well embedded in the binder, but there is enough chip above the binder to maintain contact with vehicle tires. Typically, about 70% of the chip height should be embedded, based on the assumption that the chip layer is as thick as the average least dimension of the chip. Therefore, the binder application rate needs to be calculated to produce a layer of about 70% of the depth of the chip average least dimension. There are several sizes of chip as shown by this table. The larger chips are grades 2 to 4 and are primarily used for single coat or as a base for two-coat seals. The smaller chips are grades 5 and 6 and they are primarily used to fill the voids between coarser seals. So the smaller chips range between 2.5 and 6 millimeters for the ALD, the average least dimension, while the larger chips range between 6 and 12 for the average least dimension. Chip is produced at quarries by crushing the parent rock and then screening it using a series of screens. Note that a chip mix has aggregates of all of the same size and it is a uniformly graded aggregate.